Hello. I wanted to do another problem from the reading for this week. This is Theorem 4.2.5, Problem 3. This is one of the left to you as an exercise problems. And again, you've got lots of exercises to do, so I thought I'd give you a couple examples of a proof where you haven't already seen it written down and you can kind of hear someone walk you through it. So we have R is a relation from set A to set B. We're supposed to show that the range of the inverse relation is the same as the domain of the relation. And that, of course, seems intuitive just because we've all worked with functions that, depending on the nature of them, have inverses. But we're going to do this in very general terms. So we will start. This is actually going to be very similar to the other examples from this theorem, or other parts of this theorem. So we are going to let A be an element of A. We're going to say that's an arbitrary element. And remember that R takes things from A to B, so R inverse takes things from B to A. And so that's why we're going to let A be an arbitrary element of the range of R inverse. And now we can say, now this is just straight appealing to the definition. Then A is in the range of R inverse if and only if, and this is a biconditional, so if we can get to A being in the domain of R, then we're done. And so what does it mean for A to be in the range of R inverse? It means there exists B in the set B such that the ordered pair B comma A is in the inverse relation. Remember, a relation and its inverse is a set of ordered pairs. So A is an element of the range of R inverse if and only if there is a B in set B such that the ordered pair B comma A is in the inverse relation. And then this is true if and only if, and then we're just going to say what does it mean to be an R inverse. There's a B in set B such that the ordered pair AB is in R. And in turn, we'll say that's true if and only if. Now this means A is in the domain of R. And since since A was an arbitrary element of the range inverse, or the inverse relation, excuse me, and we were able to show that is logically equivalent to A belonging to the domain of R. And that means our proof is complete. Please ask me any questions you have about this. I hope it was helpful.